Hello and welcome to a brand new unit in Algebra 2, and this is Unit 5, and this is talking about rational functions. So the first thing I want to talk about with rational functions is rational functions are functions in fraction form. Okay, so these are functions in fraction form. Okay, so we're going to talk about that. So before we do anything with rational functions, we have to talk about exponents. And specifically, we're going to talk about negative exponents, okay? So before we talk about what a negative exponent is, I need to kind of introduce it to you so you kind of understand what it means. And so when I talk about exponents, let's talk about multiplying exponents, okay, or multiplying numbers with exponents. So multiplying. Okay, so let me just give you a couple of examples, okay? So let's just say that I have say 3 cubed times 3 to the 5th power, okay? And if I wanted to simplify this and combine these, okay, notice how we have a common base. Okay, the 3 is the base, and this 3 and this 5 are the exponents, okay? So when I do this, when I do 3 cubed, that means I'm doing 3 times 3 times 3, okay? If I'm doing 3 to the 5th power, then I'm multiplying that, so here's that group, okay? And then I have 3 times 3 times 3 times 3 times 3, okay? I have 5 of them. So if you're multiplying all of them together, okay, 3 and then you add 5, then really what we're doing is we're doing 3 to the 8th power, okay? So then let's think of another one. Let's do another example here. Let's change it up to a variable. Let's say that you have, say, x to the 4th power times x to the 6th power, okay? And so you would take x times 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 x, 1, 2, 3, 4, times x. So I have 1, 2, 3, 4 of them. That comes from x to the 4th. And then I have 1, 2, 3, 4, 5, 6 of them. Comes from x to the 6th. So how many total do I have? I have x to the 10th. Okay. So the rule of thumb is that when you multiply, okay, multiplying numbers with a common base. Okay, multiplying with a common base, and by common base, I'm talking about like the 3 here, okay, and the x is here, all right? That's common base. So multiplying with common base, that means that you add your exponents, okay? And notice how I did that. You know, if I did 3 and 5 and added them together, it gave me 8. Okay, if I had 4 and 6 added together, it gives me 10. So with a common base, and this means that you're going to add your exponents, okay? So add your exponents. Okay, so now, so I've got that part, okay? So multiplying with a common base means we're going to add our exponents, okay? But what if we do division with a common base? So division with a common base. Okay. And so let's look at an example. Let's just take, say, 4 to the, let's do 7, and then divide that by 4 to the 4th, okay? And so what we would do is we would multiply this out, okay? And if I have 4 to the 7th, I've got 4 times 4 times 4 times 4 times 4 times 4, and then times 4. And then divide that by 4 times 4 times 4 times 4. Okay, so I have 7 up here, 1, 2, 3, 4, 5, 6, 7, and I have 4 down here. Now what I can do here is these divide out. 4 divided by 4 is 1. 4 divided by 4 divides out, these divide out, and these divide out. So then you're left with 3 of these, 4 raised to the 3rd power, so 4 cubed. Okay, so let's do another example here real quick. Okay, let's do say m to the 6th power divided by m squared. Okay, So I would have m times m times m times m times m times m, 6 of them, divided by 2 of them, m times m. So what happens is the m's divide out here, and I'm left with 4. Okay, so I get m to the 4th. Okay, so now you have to think about, okay, how do I get 3 by using the exponents of 7 and 4? How do I get 4 by using the exponents of 6 and 2? Okay, and so in reality what you have here is you end up getting, this is 4 to the 7 minus, or 4 power, okay, which gives you 4 to the 3rd. Here you are given m to the 6 minus 2 power, which gives you 4. Okay, so what we do if we're dividing is we subtract our exponents. Okay? So then let's think about something like this. Okay, let's come over here and let's kind of think about the introduction of the negative exponent. All right? So if we talk about the negative exponent, really what we have is we're going to do, let's just think of an example here of like, say, 4 to the 2nd power divided by 4 to the 5th power. Okay, and if we think about, dividing our exponents, then we get 4 to the 2 minus 5 power, which gives us 4 to the negative 3. Okay, so now, but let's, and that's all fine and good. This is what gives us a negative exponent. But let's do this the other way. Let's do it, where you had the 4 squared over the 4 to the 5th. Let's do it so you had 4 times 4 over 4 times 4 times 4 times 4 times 4. Okay, now the 4's here divide out. These divide out, and these 4's divide out. So then you're left with 1 over 4 cubed. So wait a minute, I got 2 separate answers from this, okay? When we did it using the properties where you subtract your exponents, I get a negative exponent. But if I do it where I do the long part, okay, where I multiply everything out and I divide out what I need to, then I get 1 over 4 cubed. So here's the thing that we need to see, okay, is that these two things here, 4 to the negative 3, is equivalent to me doing 1 over 4 cubed. Okay, so the rule of thumb with your negative exponents is that if you have a negative exponent, you move it down to the denominator and you make it positive. Okay, and then the same thing happens when, if you've got, say, 1 over 4 to the negative 3. Okay, that would be equivalent to me saying 4 cubed, okay, over 1. And I'm going to put this over 1. Okay. So when you have negative exponents, to make them positive, you move them to the other side. You move them on either on the top or the bottom of the fraction, okay? And that's what all this kind of stuff down here means, okay? Is that when you have negative exponents, okay, you take it and you move it and put it down into your denominator, okay, or vice versa, okay? Now, all right, so now that's all I've got right now. Okay, so the same thing here. An example of that would be 5 to the negative 1. That's equal to 1 over 5 to the 1st, which is equal to 1/5, okay? Okay, so let's look at simplifying expressions. What I want to do is I want to simplify this expression here, 4 to the 4th times 4 to the negative 7. Okay, so what I want to do, all right, so let's kind of do this. It says, to simplify, you got all these different things. Use properties of exponents, write the expressions with positive exponents, and then evaluate the numerical powers. Okay, so first, when we have simplified exponents, we have no parentheses, no common bases, no negative exponents, and no powers of numbers. Okay, so let's take a look. Let me write this out. 4 to the 4th times 4 to the negative 7. So remember what we do when we multiply numbers with a common base. We add our exponents. So what I would do here is I would say, okay, well, this is really just 4 plus negative 7, okay, which then that's going to give me 4 to the negative 3 power. Okay, and if that gives me 4 to the negative 3, then I'm going to get, that's 1 over 4 cubed. Okay, and 4 cubed is 1 over 4 times 4 times 4. So that's going to be 1 over 4 times 4 is going to give me 16. And then times another 4 is going to give me 64. So this is going to be 1 over 64. Okay, and this is what we want. Okay, we want to get to a point where we have just a single number or fraction, okay, and no exponents, no negative exponents, no nothing. Okay, we have that. Now, there's another way to do this, okay, and I'm going to show you that real quick, and that's just going to be, I'm going to rewrite this out and say 4 to the 4th times 4 to the negative 7 power, okay, and I'm going to rewrite that as this. I'm going to do 4 to the 4th over 1 times 1 over 4 to the 7th power, okay? And so what this gives me, all I did was change my negative exponent to one with a positive exponent, okay? So then what I can do is I can rewrite this and I can say, okay, well, this is just 4 to the 4th over 4 to the 7th, which I would then subtract my exponents. And so you get 4 to the 4 minus 7 power, okay, which then gives you 4 to the negative 3, which then gives you 1 over 4 cubed, not to the 4th, 4 cubed, and that would equal 1 over 64. So, guys, there's a number of ways of doing this. You don't have to follow everything I do exact, just get the right answer, okay? And so just use your properties that you know how to do, all right? And that's that. Okay, now let's go ahead over here and let's do rewriting these expressions. So they want us to simplify, God, come on. They want us to divide negative 3b to the 4th by 6b to the negative 8, okay, and b cannot equal 0. All right, so I'm going to rewrite this, okay, and I'm going to say, okay, this is negative 3b to the 4th divided by 6 times b to the negative 8, okay? So, something like this, we could still do. There's a number of ways to do it. I'm going to do it a couple different ways. Okay, I'm going to rewrite this as negative 3b to the 4th over 6b to the negative 8. Okay, so one thing I could do is I could just go ahead and do what I do with a negative exponent and take this value of b to the negative 8 and bring it and put it in my numerator. Okay. So this would give me negative 3b to the 4th times b to the 8th, all divided by 6, okay? And then we would add our exponents here because we're multiplying, and so I get negative 3 times b to the 4 plus 8 power, okay, divided by 6, and that's just going to give me, what is that, negative 3 times b to the 12th over 6. Okay, now I need to simplify my numbers. So negative 3 divided by 6 is going to simplify to negative 1/2. So this is negative 1 times b to the 12th, over 2. Okay, which really we'd want to simplify this and write it as negative b to the 12th all over 2. And that's it. Okay, so that's what we do. All right, so then, okay, that's one way of doing it. Okay, another way would be to just kind of, do your operations that you know about, okay? Since you're dividing these numbers, you just subtract them. So you would get negative 3 times b to the 4 minus negative 8 power, okay? And then divide that by 6. All right, so that would give you, negative 3 times b to the 4 plus 8 power over 6, okay? Which would then give you negative 3 times b to the 12th over 6. All right, so you're going to get the same thing. So negative 3 divided by 6 simplifies to negative 1/2, and so this would just end up giving us negative b to the 12th over 2. Okay, so you get the same thing, all right? And that's the idea. Okay, so you don't have to always do, there's a number of ways of doing this. Okay, and it kind of just depends on how you want to do it. All right. Now, before we move on to this next one, what I want to do is talk about raising powers to a power. So let's come over here and let's write this piece in over here. And I want to do, I'm going to call this raising an exponent to another exponent, to an exponent. Exponent. Okay, so what I have here, let's just say I have, say, x squared, and I want to cube that, okay? And the indication is that I have something raised to a power raised to another power, all right? And so what I would do then, you know, to think about what that means I have x squared times x squared times x squared, okay? And if we have these and we add those together, and that's going to give me a total of x to the sixth. So how do you use the numbers of 2 and 3 to get 6? And the reason is that you multiply your exponents. Okay, so multiply exponents. Okay, and that's that. All right, so, you know, let's take a look at, you know, simplifying a power of a quotient. Now, when we have a quotient like this, okay, let me show you what happens. Okay, when I have this, really means I'm going to take x cubed and, you know, multiply that by -2, okay, because I'm raising a power to another power. And I'm also doing it to the denominator. Okay, so I have x to the -1 times -2. All right, and so as a result, what you get here is you get x to the -6 power divided by x squared. Okay. And you can do this a number of ways. You can move this down and then add them, or you can just go ahead and subtract. I'm going to go ahead and just subtract. I'm going to do x to the -6 minus 2, which is going to give us x to the -8 power. And then this just then becomes 1 over x to the 8th. Okay? And that's that. Okay, we can look at this another way. Let me do this another method. Okay, and so let me rewrite it as the quantity x cubed over x to the -1, quantity to the -2. What I can do is I can simplify on the inside before I raise it to a power, okay? So what I'm going to do is I'm going to redo this. I'm going to say, okay, well, this is really just x cubed minus -1, okay, if you think about it that way, and then we're going to raise that to the -2 power. Okay, so then this is going to give me x to the 3 plus 1 power raised to the -2. And then I've got x to the 4th, all right, raised to the -2, which gives me x to the -8th power, because I multiply those. And then that's going to give me 1 over x to the 8th, okay? So, you know, I'm doing this two different ways, okay, going about this in two different manners to get them. So I can either, you know, distribute and multiply every exponent by the -2, or I could simplify this fraction on the inside, get a single thing, and then multiply it by -2. It doesn't really matter, okay? So what I typically like to do, especially when they get a little bit more complicated, is I try to simplify what's inside the fraction before I do the exponents, okay? And so let's go ahead and let's take a look at that. What I want to do first is look at the 20 over 10 portion, okay? And that's just going to, 20 divided by 10 is just going to give me 2, okay? So let me simplify this to 2 over 1, okay? And then if I have x to the -3 over x to the -1, let's rewrite that as x to the -3 minus a -1 power, okay, before we raise all this to the -2. So then what happens is I'm going to get 2, and this is going to give me x to the -3 plus 1 power, and then raise that to the -2, okay? And then what I have is I'm going to get 2 times x to the -2, and then raise that to the -2 power. Okay, now because I'm multiplying these two numbers here, okay, I need, when I have raised this to the -2, okay, I'm going to do 2 to the -2 times x to the -2 times -2 power, okay? So when I have 2 to the -2, that's just going to give me, 1 over 2 squared, and this is going to be times x to the positive 4 over 1. Okay, when I have fractions, I'm just going to multiply across. So 1 times x to the 4th is just going to give me x to the 4th, divided by 2 squared is going to give me 4 times 1, so that's just going to give me 4. Okay, and there's probably other ways of doing this, but to me, I think this is the most simplest way. You know, the key is, guys, you know, you got to get to a point where you're doing this by, you know, in your head. But, you know, we just need to be able to simplify these and operate with our exponents. Okay, so get started on the assignment. And if you have any questions, let me know. See ya. Bye.